Welcome to the lecture. This is lecture number 3 and the title is Progressions and Series, Growth and Decay Curves. So, as we discussed in the last class that last lecture we discussed about the terminologies like exponents, exponential functions, then we also discussed about logarithmic functions and all. So, we will further get acquainted with a few more mathematical terms and particularly those which are typically used in the financial mathematics. So, we will discuss one by one. The topics which we will deal with will be the progressions, and we know that there are different types of progressions. We have arithmetic progression, we have geometric progression, we also know about harmonic progression which is normally not used. So, we will discuss and review some of the traits of these progression series. Then we will also discuss about other kind of progression like recursive progression, which is somewhat newer. So, we will know about the traits of this recursive progression. We have infinite geometric progression, that is also many of you might be knowing, and then we will also have the overview of the growth and decay curves. So, we will switch to the different type of progressions. So, as we know that first is the arithmetic progression, and arithmetic progression, as we know that this here you have a series of numbers, and in all these progressions basically you have certain rules are followed, so that you can predict once you know certain things about the series or progression where the number progresses in a particular manner, then you can predict about the number which will be coming at suppose certain position, or you have to find the sum of these numbers. So, these are typically used and they are of use when we deal with such analysis. So, in arithmetic progression basically the important thing is that you have two terms which should be known to you, and that is A and D. So, A is known as the first term and D is the common difference. So, basically the arithmetic progression is defined as that progression where the successive terms or the consecutive terms differ by a constant number that is known as common difference. So, if the first term is A, then second term will be A plus D. So, you know that the difference between A plus D and A is D. So, then the next term will be A plus 2D, then you have A plus 3D, like that. So, it will go. So, in these type of progression series we can find any term. Suppose we want to find the nth term of this progression. So, for nth term basically the formula is A plus n minus 1 into D. As you know that the second term is A plus D, third term is A plus 2D. So, this way you can get the nth term as A plus n minus 1 into D, and we also need to sometimes know the sum of the terms and sum of the suppose n terms. So, if you are required to know the sum of first n terms, so again you can find it, and you must have studied, many of you, how we find the sum of the n terms, and as you know that it will be n by 2 into first term plus last term. So, you have if you know the last term you can have it, otherwise if you know the first term and the common difference, then it will be n by 2 into 2A plus n minus 1 into D. So, this way we try to have the sum of the first n terms. So, if this is these are the formulas which are used in such kind of progression, and many a times you will require to use it when we deal with the financial mathematical concepts, like if we will see that how the payment is made. Suppose you have taken a loan and you have to pay it. So, you want to pay it in a way that every time you are going to increase by certain amount. So, basically that is in a arithmetic progression form. So, suppose in the first month or first year you have paid 1000 rupees, second year suppose you are paying every year 2000 more, it means second year it will be so first year if it is 5000 suppose, second year it will be 7000, then it will be 9000. So, this way you can know that in particular year what will be the amount of that will be paid to repay the loan amount or so. So, this way these are the places where the arithmetic progressions are used. Then similarly you can also at any particular point also if you need to add many terms which are in progression, arithmetic progression especially, then you can use these formulas and you can get those values. So, you may have different types of series and then you can solve them. Now, the next progression which is very important will be your geometric progression. Now, as you know that the geometric progression, in the geometric progression in place of common difference which is there in arithmetic progression, you have a common ratio here. So, basically the first term will be A and then second term will be AR, that is your common ratio. So, second term to first term is having a ratio that is fixed. So, next term will be AR square, then it will be AR cube and all that. So, you have A as the first term and R is the common ratio. So, in the case of such cases where the increase is in terms of a certain factor, that is R. So, that is basically the ratio is there bit from AR to A is ratio is R, or AR squared to AR is ratio is again R. So, like that. So, you have a common ratio which is maintained between the consecutive entities, and that way this is known as a geometric progression. And if we talk about the geometric progression, then in this also you have suppose you have to find the nth term of a geometric progression. So, nth term in the same way as you see that if you have second term it will be AR, third term is AR raised to the power 2. So, similarly in the nth term it will be A into R raised to the power n minus 1. So, this is how you get the nth term, and this is basically denoted by Tn. So, that will be your nth term. Then I hope that you must have the idea about how to add these terms. So, once you add them, so after adding, so if you want to find the sum of first n terms, so first n terms you are adding and you have some of the calculations which are performed. You must have done it in the algebra courses, and that is defined as Sn, and that is basically A into Rn minus 1 by R minus 1. So, this is how the in the geometric progression you find the sum of the first n terms, and this will be the case normally when the R is more than 1, and if it is less than 1 you can have you may have also the case like A into 1 minus Rn divided by 1 minus R. So, in that case you will have, because once R is less than 1, in that case both will be negative. So, anyway you can use that also, but in that but otherwise you use this formula A into 1 minus Rn divided by 1 minus R depending upon the value of R as more than 1 or less than 1. So, this way you will have the formula for the Sn. Now, you may have sometimes to find out for the geometric progression which is having there is infinite series, and what will be the sum of that series, and normally that sum is defined as A by 1 minus R. So, basically R has to be less than 1 in that case. So, what happens that in that case this will be tending towards 0, and then that is why it will become as s equal to a by 1 minus r. So, this is for that infinite geometric series and the sum of the first n terms. So, you may be many a times you may require to find, suppose you are given one geometric progression, and progression is something like 9 minus 3 and 1, and suppose this is a type of series which is given to you, and you are to find the so question is that to find the sixth term of this series. So, as you know that by looking at this progression, you can see that you have a common ratio, that is minus 3 by 9, that is minus 1 by 3. So, your r becomes minus 1 by 3. You can also get from 1 by minus 3. So, it will be minus 1 by 3. So, same way, and a is basically 9. So, if you have to find the sixth term, so sixth term will be T6, and that you will be having a into r raised to the power 5. So, what will happen that it will be a into, that is 9, and then minus 1 by 3 raised to the power 5. So, since minus is there and it is raised to the odd number exponent is the odd integer. So, it will be minus, and it will be 3 into 3 into 3 raised to the power 5. So, 3 raised to the power 2 is anyway cancelled. So, you will have 3 raised to the power 3. So, that will be minus 1 by 27. So, this way you can use such kind of progression formulas to find any particular term, or even you can find the sum of the first 10 terms. In that case, you can have the formulas like a into 1 minus r n by 1 minus r. So, that way you can have these values. Then now next type of progression, which is also very popular in the case of financial studies, is the recursive progression. Now, as you know, we were discussing about the geometric progression, and that is also many a times used. Especially you can say that many a times it will be increasing by a certain factor, or the payment which you are making every time. So, that is basically in a factor way it is increasing. So in those cases you can see that it is having a geometric progression type of pattern, and these formulas may be useful under such circumstances. There is another type of progression which is also very much common, very much popular, and that progression is known as the recursive progression. And in the recursive progression, what is there that the third term, for knowing the third term will be known as the sum of the first two terms, first term and second term. So, here basically each term is sum of two terms preceding it. So, in these cases if you know the two terms, then you can predict the third term, and I mean, rather than use of the common difference or the common ratio, here basically you have to know the first two terms, and this way you find the next term. So, the standard formula will be a n. If you have to find, it will be a n minus 1 and a n minus 2, its sum. So, you have to know the n minus 1th term and you have to know the n minus 2th term, then you can add this and you can get the nth term, and this way you are getting the any term you can predict. So, that type of progression is known as the recursive progression. Now, suppose you are told that there is a progression known as, so if you have a question like a progression is the recursive progression and your series is going like this, and you have to find the different terms in this case. So, as you know that the first term and second term is known. So, you have your third term. So, your third term, that is T 3. So, it will be 5 plus 7, 12, because T 1 is 5 and T 2 is 7. So, as we know that is a recursive progression, then your third term with T 3 will be 5 plus 7, 12. Similarly, T 4 will be T 2 plus T 3. So, T 2 is 7 and T 3 is 12. So, it will be 19. Similarly, T 5 will be T 3 plus T 4. So, T 3, as we know that T 3 we have got 12 and T 4 is 19. So, it will be 31. So, similarly, T 6 will be 50. So, this way it will be going on. So, such is the such kind of progressions where you find these values, they are known as the recursive progressions. So, you may have any question like you find the 10th term of certain type of recursive progression where first and second term is given. So, in those cases you can find that particular value of the term which is to be required. So, such progressions are known as the recursive progressions. These are the normally the kind of progressions which are required in our financial mathematics courses. Now, we will discuss about certain other terminologies which is required in the case of while we study this course. So, there is growth and decay curve. So, you have growth and decay curves. So, basically these curves are the graphic representation of the exponential function of the form. So, so they are basically graphic representation of an exponential function of form y equal to a b raised to the power x. So, we have come across such kind of functions, and they are basically used to represent these growth and decay curves. Now, in this case, depending upon the value of these parameters a, b and x, you have either growth curve or decay curve. So, when now you have a is a has to be positive, and the value of b basically, and value of b determines whether it is a growth curve or a decay curve. So, a has to be 0, more than 0, and the b, the way your b is, so that only will determine that whether it is a growth curve or it is a decay curve. Now, for a growth curve, now as you know that first of all the terminologies like growth or decay, it is because of certain type of pattern where something is growing, something is increasing in certain way. So, that is why it is a growth curve, and similarly because many a times the epidemic grows. So, that is the kind of how it is growing. So, that is why on that line this term growth curve is being used. Now, for a growth curve basically b has to be more than 1, and for a decay curve now this b value they have has to be larger than 0, but it has to be less than 1. So, your value will be going like 0 to 1. So, this way if the function, if you know the function where a anyway has to be positive number, and if the b is more than 1, then it is a kind of growth curve, and if it is you know in between 0 to 1, then it is a decay curve. Now these growth and decay curves, they are basically used for predicting many times the economical or biological growth. So many a times you have growth of bacteria or spread of the epidemic. So they are used for the so these growth curves are used. So growth curves use, so typical applications in economic or biological growth, like growth of bacteria or an epidemic. So many times if you see that when the epidemic will spread, so it will spread in a very exponential way, or it will be in a different way, that is basically a type of growth curve. It will not grow in a constant by constant increment or so. So that is why in that line it is done. Similarly, you may have the application of decay curves also, example of decay curves also. Now many a times you use the decay curves, like you have economic decline or infant mortality. So on all these cases, we normally use these growth or decay curves, which is very much used in a practice in economic cases. Now if you look at certain examples, suppose you have if you have suppose an example, like you have a spill of crude oil in ocean, and suppose you are estimating this spill of the crude oil in the ocean, and the function is y equal to 2 into 5 raised to the power x. So when you have x as 0, so it is the day that under this pipe has broken. So x equal to 0, it is representing is the day the underwater pipe broke. Now negative x will represent the the loss or the crude oil spilling before today, and the positive x will tell you about the time in the advance, that is maybe next day or day after tomorrow or so. So that way, so negative will represent the time in the past and the positive will represent the time in the future. So the amount of spill which will be growing, it will be following this way, and if you look at this graph, now from this you can predict that what will be the loss on a particular day, and then putting that value x at that point, you can have the prediction of the spillage of the crude oil into the sea. So you can predict it. Now if you try to draw the graph of such spillage, so what you see is you will have -1, you have -2, here 1 and 2, and these are the days. And if you look to the further the how it is growing, so for 0 it will x is 0, you will have certainly here it is 2, and then it is and then it will be going negative, so it will be coming out to be 0, and then it will be further moving like this. So this way this is an example of growth rate, and if you look at the values. So, if you have x as days and if you have y as 100 of barrels. So, you can use this formula and you can find the what is the spillage. So, what you see is that once you have this is also in terms of hundreds of barrels. So, that is why in hundreds of barrels. So, what you can do is for the today, that is 0, you will have 5 raised to the power 0 1. So, it will be 2. The first day it will be 2 into 5. So, that is your 10. Second day, I mean 5 into 5 25 into 2. So, that is 50. Third day it will be 5 into 5 into 5. So, 125 into 2. So, that will be 250. Similarly, fourth day it will be 625 into 2, 1250, like that it will go. If you go to the previous day minus 1, so it will be 2 by 5. So, it will be 0.4. Next to that, if you take minus 2, so day before yesterday. So, in that case it will be minus 2. So, 1 by 25 into 2. So, it will be 0.08. So, this way if you go, it will be moving towards 0. So, that way it will move and go towards 0. So, these are the type of the growth curves which we normally come across in the in these financial cases, and you can predict that what will be the spillage as the time progresses. Then you may have also the example of the decay curves. So, suppose for the decay curves, one example is about the infant death in the country. So, in those cases if that is being basically predicted by or estimated by the function. So, the function becomes 10 raised to the power 5 into 0.89 raised to the power x. So, this is so x, when x is 0, it is the reference year. So, this is a reference to any year. Now, in such cases x, if x is x equal to 1, so that will be year after. So, that will be x equal to 1. So, that is a reference to year after. Similarly, if you take the negative values, it will go the year before. So, what we can see that here, if suppose the x is 0, then it will be 10 raised to the power 5, and otherwise if you have x raised to the power 1, so it will be 0.89. So, what you see is if you take any year as the reference, and then if you try to find the values. So, suppose when you are calculating in the reference year, in that case y equal to 10 raised to the power 5, and then you will have 0.89 raised to the power 0. So, it will be 10 raised to the power 5. So, you will have 1 on that, you have 5 zeros. So, it will be that. Now, if you try to have, so if suppose in this is in a particular year, suppose say in 2011, suppose you have calculated this as the infant death in the country. Now, if you want to find, suppose in 2014, if you want to calculate in 2014, then for that the x will be, so from 11 onwards you will have plus 3. So, x will be 3. So, for 2014 if you have to predict, it will be 10 raised to the power 5 into 0.89 raised to the power 3. So, this will be basically coming as 7497. So, this way you can have the prediction of these decay curves. So, if you want to go in the back, if suppose you want to go towards the back, if this is the reference year, and if you want to go towards the back and if you want to predict in 2001, in that case you are going 10 years back. So, x will be minus 10, and in that case y will be 10 raised to the power 5 and into 0.89 raised to the power minus 10. So, it will be divided by 0.89 raised to the power 10, and in that case if you look at, if you calculate, it will be 320,700. So, what you see is that this value is quite larger as compared to the value which is now. So, basically the value which is in the past, it is larger, and in the reference year, from here if you move onwards, you will have the decay in the value. So, that is a decay curve. Similarly, you have, so this basically depending upon the value of this b, you will have the growth or the decay curve, and you can predict these values. Now, when we talk about these growth and decay curves, it is further worth mentioning to tell you that you may have these growth and decay curves. So, you may have the growth and decay curves with the natural logarithm as base. So, with natural logarithmic base. So, in those cases what the function becomes a e raised to the power x, and otherwise y a e raised to the power minus x. So, in these cases you have the use of this natural logarithm, and this e is used, and this e value, as we know that it has a particular value 2.71828. So, this way we use that, and based on that you can find these values. So, these are the functions. So, maybe you may have some examples, like suppose you are having the annual profit for a firm, and the annual profit is basically going as if it is like 3000 plus 7.5, so 7500, and then exponential raised to the power 27x. Now, in this case x is how long the firm has been selling the product. So, based on that you can have these x values, and you can get the calculations, you can do the calculations and find the results. So, so as you see that here this will be a type of growth curve, and you can find these values accordingly as the function comes out to be. And suppose you are going for finding some values, you can have the value here and find those values. That this may be there may be negative sign here, and that may have the different values in those cases. So, that way you will have depending upon the different functions, you will find these values, and they represent these growth and decay curves, which will be further discussed in our lectures to come. Thank you very much.